An AC generator consists of 30 tons of cross-sectional area 0.005 meters square and resistance 100 ohm. The coil rotate magnetic field 0.5 Tesla at frequency 20 Hz. So question number 1, maximum induced EMF. So for the generator consists of a coil. So if the coil rotates, EMF maximum produced for this system is given by the equation number of turn and time magnetic field strength B and area A time angular frequency. So number of turn is 30 and the B is magnetic field strength is 0.5 Tesla and the area A is cross-sectional area A is 0.05 and the omega. So what is the omega here? So as you know, angular frequency omega is given by you can relate to the frequency, or omega is 2 pi f and the frequency is equal to 20 Hz, right? So 20 Hz, so meaning you can find the omega here is equal to 40 pi. So you can use the omega to the equation here. So now you can find the Emax is equal to 94.25 volt, right? And number 2 is maximum induced current. So this is E or Emax when the coil rotates, or AC generator coil induce EMF 94.25 volt, meaning you can calculate the current flow if you have the voltage or EMF 94.25. so meaning if you use the Ohm's law, V is equal to IR. So now V is the potential difference is referred to the V is induced. So this is the value of the potential or induced electromotive force is equal to IR, and value of the E or E maximum is 94.25, and the resistance is 100 ohm. Now you can find the value of the current I. So current I is equal to, or current maximum or maximum induced current is equal to 0.94 ampere. So this is number 5. Next question. 400 tons solenoid has cross-sectional area A 1.81 exponent minus 3 meters square, and the length of the solenoid 20 centimeter, and current in the solenoid flow to 3.4 ampere. Number 1, calculate inductance of the solenoid. So meaning you can find the inductance of the solenoids, or L, is given by or you can refer to the equation nu naught n square divided by length of the solenoid and times A. So this is the inductance equation for the solenoid. So all the item here, nu naught is constant value, this is 4 pi exponent minus 7, and the n is its number of turns is 400. Okay, this is square, right? And the area A is cross-sectional area is 1.81 exponent minus 3 meter square, and the length is given by the equation 20 cm. So use a USI unit. This is times 10 minus 2 meter. Now you can find the value of the L here. So the inductance of the solenoid is equal to 1.82 exponent minus 3, and unit for the inductance is H Henry. And number 2 is energy store. This is number 1 and number 2. So still you just use the equation for the energy store in the solenoid is half Li square. So the value of the L here is a 1.82, and the current flow is 3.4, right? So 3.4, this is square. So now you can find the energy store in the solenoid is 1.05 exponent minus 2 unit. This is minus 2, right? Sorry, this is minus 2, and this is energy, so unit is a joule. Number 3, calculate induced EMF in the solenoid if the currents drop uniformly to 0 in 55 milliseconds. Now you can refer to the equation that relate between EMF and inductance L. So as you know, EMF or induced EMF is equal to negative L di dt, right? So this is equation that you can use or relate between induced EMF and inductance. So now the value of the L here, yes, this is from the answer number 1, right? 1.82 exponent minus 3, and d2, the change of time is 55 milliseconds. So 55 milli is times 10 power of minus 3. And now the change of current from maximum current is 3.4 and drop to 0. So now you can find the change is 34 minus 0, or the change is 34. And yeah, you can find the induced EMF in the solenoid is equal to 0.11 volt. And number 4, explain why the spark jump across the contact of the switch when the switch is disconnected. So meaning when the switch disconnected, meaning no current flow in the circuit, but a spark jump across the contact of the switch, meaning the current stay in the circuit even though the current or switch is disconnected, because the current is come from the induced EMF or back EMF when the switch is disconnected, because of the inductor store energy in a magnetic field. I use a thing that this is a flux, meaning the inductor have a energy stored in the inductor, and the energy stored inductor to produce current, and the energy is come from the rate change of flux at the time t. Thank you.